This part will show our study case in TEC Data Management focusing on matching entity process. We match both entity name and entity address. This project is executed in Spark cluster and developed in Python language. We cover our finding from data, method that we use, and technical section which explain technical part of our project. The result is shown in the final section of this report. Our study used MSBR and trade data that were recorded in July, August, and September 2015. We took the distinct data to be processed. In total, there are approximately 300,000 unique MSBR data and approximately 300,000 unique trade data. In this section, we show our finding in matching entity name process. All of the following cases are listed with the example given. We found that there are several ways to write company's title, so we need to clean those titles to get the clean name. We listed the title terms like SDN, BHD, Co, Malaysia, and all related terms that refer to company's title. The table shows the different name from raw MSBR and raw trade data that refer to the same company. After removing the company's title, both clean name MSBR and clean name trade data are similar. Some company may use English words in their name, so we found the probability of different grammatical number error. The table shows same terms that return in different grammatical number. As we will do text matching, we found that space matters. Different spacing will fail full matching process. We found that adding special character could mislead the full match process. As we know that raw trade data may be input manually to the system, small mistype may be found. Another problem that we found is some data may be written in the short form. In this case, we found that PKG means packaging. Next, we found that some company may write the branch details in their name. We do pre-processing before text matching to handle the problem that we have listed before. This section will explain the pre-processing part. First, we clean the data to get clean name form. We list some terms that belong to title list and remove it from the entity name. Some of those lists are shown in the table. We also remove unwanted character. Next, we do word tagging to divide the clean name into two parts, core name and attribute name. This method will simplify matching process when the full match processing failed. We listed attribute terms as a dictionary. We tag the entity name word based on those lists. All attributes that located between two cores will be listed in the core name. To handle space problem, we add no space form in our pre-process stage. We also add one variable as a no space and special character forms to handle special character problem. We also remove branch detail from the clean name. The following table shows the result of pre-process stage. Each variable are added as new columns and will be added as input in the text matching process. This section will give the brief explanation about the method that we use in text matching process. We only use two methods, fuzzy string matching and compare number insensitive equality. Fuzzy string matching is a common method that is used to do text matching. This method counts the ratio of similarity between two strings. The ratio is in range between 0 and 100. Full match is obtained when the ratio is 100. Fuzzy string matching uses Levenshtein distance that measures the minimum number of edits that you need to do to change a one-word sequence into the other. Second method, we use compare number insensitive equality to handle different grammatical number problems. This method compares words of different plurality. For example, plantation and plantations will be detected as the same term. This will help full match detection when the difference of two names is only caused by different grammatical number of those words. We are covering technical section in the next slide. It will explain about the process flow, code snippet and the technical specification in this project. Below is the TEC matching process flow. We take MSBR and trait data that's stored in the database to do pre-processing in separate process. All codes are written in Python language. We do pre-process in Python. The result then inserted to HDFS. All matching process is executed in Spark. The output will be saved in Elasticsearch to ease the next processing. As we discussed in the pre-process section, this stage will add new variable as a new column. The result will be called clean data and be used in matching process. This code snippet shows excerpt of pre-processing data in Python. In this part, we show 4 parts: data cleaning, pattern detection, word tagging, and columns adding. Below are listed some command that is used to do work with HDFS. This command is used when inserting clean data into HDFS. For example, in the snapshot, we show how to insert data from local directory to HDFS directory. The diagram shows matching algorithm that we use to define the matching entity name result. The process is started when it reads data from HDFS. First, it matches the clean name from MSBR and trait. If the ratio is 100, it will be classified as full match. If not, next step is to check whether it has different grammatical number. If yes, it will be classified as full match. If not, it matches the no space from MSBR and trait. If the ratio is 100, it will be classified as full match. If not, it will match the no space and character from MSBR and trait. If the ratio is 100, it will be classified as full match. Next, it checks if both companies are similar but came from different establishment. Then, it checks if both companies are partial match. It will be categorized as partial match if either ratio of attribute score is 100 and ratio of core score is more than 88, or ratio of core score is 100 and ratio of attribute score is more than 88. Lastly, it checks if both attribute score and core score are more than 88. If yes, it will be categorized under QA/QC. If otherwise, it will be saved in the temporary memory. The diagram shows matching algorithm that we use to define the matching entity address result. All full match, partial match, and QA/QC will be processed into matching entity address. We have two sets of address in MSPR data, so we do the match process for both of them. First, it checks into set A. If all state, postcode, and town are matched, then it is classified as address A match. If only state and postcode match but did not match the town, it will be classified as address A partial match. If otherwise, it checks into set B. If all state, postcode, and town are matched, then it is classified as address B match. If only state and postcode match but did not match the town, it will be classified as address B partial match. If not, then it will be classified as no match address. This code shows main matching process in Python that will be executed in Spark. We define several UDF or user-defined function to do our matching process. It will then be applied to match the respective columns. The program to do matching process is written in Python language and execute in Spark using Spark submit command. Spark is used for doing parallel computation with large datasets, and it integrates well with Python. We combine the power of processing in Spark and the rich and flexible package in Python. In this project, we use Python 3.7 and Spark 2.1.1. This is the specification for servers used for matching process, consisting of 10 servers using CentOS 7 as OS, Java 8, and Python 3 as programming language. This page is mentioned about the installation steps to prepare the environment. We use Anaconda distribution to install Python. After start the environment, we test using simple program to check whether the installation is completed. We also could check the log of running application. We need to write full code in a file or package and submit to Spark using Spark submit command. We use this configuration when submitting Spark application. We could change this configuration in many more ways to get the optimum result. Here is the snapshot of terminal when the application is running. It prints current time, application ID, and its status. Here is the snapshot of terminal when the application is finished. It prints the information related to the application. We can monitor the application in web user interfaces. The Jobs tab displays a summary page of all jobs in the Spark application and a detail page for each job. The red boxes highlight matching process application. The details page can be shown by clicking in the application master or history under tracking UI columns. The details page further shows the event timeline, DAG visualization, and all stages of the job. We can check the timeline by expanding the event timeline. In the snapshot, it shows timeline of executor and timeline of jobs. And inspect detail for each stage in Stage tab. In the snapshot, it shows 7 completed stages and 1 pending stage. It also gives another details like the time application submitted, duration, and others. This last section will highlight the result of our project. The result is inserted to Elasticsearch and can be monitored in Kibana monitoring page. The page shows index name and its details. Here is the snapshot of matching process result in JSON format. In this page, it shows excerpt of index TEC underscore result underscore 0630 underscore 0 and all of its fields. Here is the snapshot of matching process result with result clean name is 100. The scenario handles company's title problem. Registered name is entity name from MSPR data. Entity name is entity name from trade data. The red box shows that XD Malaysia SDN BHD from MSPR have clean name XD. XD M SDN BHD have clean name XD. So, in the matching process, the ratio will be 100. Here is the snapshot of matching process result with result clean name is not 100, but it detects different grammatical number. This scenario handles different grammatical number problems. The underlined words are the words that have different grammatical number. Here is the snapshot of matching process result with result clean name is not 100, but result no space is 100. It handles space problems. The red box shows that M space S space T Golf SDN BHD and MST Golf SDN BHD have result clean name 89. But if we take care about space problems, it will give ratio 100. Here is the snapshot of matching process result with result clean name is not 100, but result no space and character is 100. It handles special character matter. The red box shows that I-net and I-net M SDN BHD have result clean name 80. But if we take care about space and special character problems, it will give ratio 100. Here is the snapshot of matching process result with result core name is between 88 and 100 and result attribute name is 100. We do word tagging for simplify matching process. Result of this scenario is categorized as partial matching. This result will be inserted into address matching to check whether both of those companies have similar address. The red box shows that attribute name of those entity name are marketing, so we only focus to check the core name. The first one, GUINESS Anchor, and the second one, GUINNESS Anchor, that have ratio 97. Note that with this scenario, we could figure out the difference in the core name clearly. When we do full matching process at the clean name, we got higher score because the text is longer. For example, Sun Ki Seafood Restaurant and Sun Li Seafood Restaurant have similar ratio 96, but if we only focus at the core name, Sun Ki and Sun Li only have similarity ratio 88. Here is the snapshot of matching process result with result attribute name is between 88 and 100 and result core name is 100. This scenario we focus on the difference between attribute name. Attribute name is common word that used by majority of companies, mostly to show what kind of businesses they are doing. Same core name might be used by different kinds of companies. We match each trade data into two address sets, A and B. Below is shown the result for address set A. Entity address is address detail from trade data. We extract the postcode from trade data. The last three columns show the similarity ratio of town, state, and postcode. This last section will highlight the overall result of our project. Lastly, we run the same process using new data that we recorded in December 2019. There are more than 3.6 million listed companies in MSBR data and more than 1.4 million trade data. We extract the distinct data from importer details and exporter details to get the distinct trade entity containing both name and address. Here is the distribution of similarity ratio between clean name of MSBR and clean name of trade data. We insert the matching result into Elasticsearch. Here is the snapshot of full matching entity name and full matching address A. The following table shows the matching result from unique 20,000 trade data with all MSBR data that are full match address A.